Okay, welcome back to another exam walkthrough. We're going to be understanding maximum and minimum speeds. So we've got an object here that's moving in a vertical circular motion. We have to calculate the minimum velocity of the car to maintain the circular motion, and the radius of this hump is going to be 7 centimeter. So I'm going to draw all the forces. We've got the weight here. We've got the normal contact force. So the normal contact force plus mg is going to be mv squared over r. Now for the velocity to be minimum, the centripetal force has to be minimum. And for that, our normal force has to be equals to 0. So when normal contact is 0, this will cancel out and we will truly have the centripetal force being minimum. So mg is equals to mv squared over r. So we're going to have v minimum as square root g times r. So we have square root 9.81 times 7 times 10 to the raised power of minus 2. You're going to get 0.83 meters per second. What does this imply? The normal contact force is 0 at the top and the object is in free fall momentarily. Now it says the velocity, if it's equal to 0.83 meter per second, the object is just able to complete the circle. Okay, given that we have the normal force, it's going to be 0 at the top. Now, if the velocity is going to be less than 0.83, then you cannot maintain the circular path and you will lose contact and fall down. And the velocity is greater than 0.83 meter per second, you can maintain the circular path. So I'll have three objects in front of me. Okay, you have to tell me which will maintain the circular path. This is traveling at 0.49 meter per second, 0.83 meter per second, 0.95 meter per second. You can pause the video and think about it. Okay, there's going to be A, B, and C. If you said B and C can travel in the circular path, you are right. A cannot. It doesn't have the minimum velocity. Now let's talk about the maximum velocity. So we've got a car that moves across a circular road hump. Calculate the maximum velocity of the car when it travels through the road hump. The radius of the hump is that much. It's the same thing. So the only thing that's going to be different in this example is the direction of the normal force. It's going to be out of the circle. And you have the weight acting like this. So we're going to have mg plus, actually minus n is going to be equals to mv squared over r. N is equals to 0. This cancels out. Now when n is actually going to be taking away from the weight, it's going to be subtracting out. So for our v to really be maximum, n has to be 0. Because when n is 0, our centripetal force is going to be max, because nothing is taking away from my weight. So we're going to have mg is equals to mv max square over r. You have v max, same equation, just a different understanding here. G times r. And you're actually going to get the same value, 9.81 times 7 times 10 to the raised power of minus 2. You're going to get 0.83 meter per second. Now here the understanding will be a bit different. If your velocity is less than 0.83 meter per second, then you're going to stay on the hump. If your velocity is greater than, if your velocity is equal to that, then you're just about to lose contact. If it's equal. Now if it's greater than that, then you're going to leave the road hump. If you're greater than the max velocity. Right, now to properly understand this, let's take three examples again. Okay, it's going to be 0.95 meter per second, 0.49 meter per second, 0.83 meter per second. You gotta tell me which object will be in the circular path and not leave the road at the top of the hump. Okay, which object will not lose contact basically. Okay, and which object will lose contact. Okay. So pause the video, think about it. Okay. Now, if you said A and C will lose the contact at the top, the N will be 0 for both of them and they'll lose contact and get out of that circular path or are about to do that, then you're right. A will get out of the circular path. So if you have an object and it's moving like at 0.95 meter per second and this is the Vmax, right? Then you're going to launch the object. It's going to travel like this. instead of going in the circular path. So this object will lose the contact and get out of the circular path, A. For C, it will move in the circular path, but it will lose contact at the top, just about to lose contact. So this will also lose contact. Okay, so let me just actually put the wrong sign here, and this object is thumbs up, it's going to move in that circular path. So it's going to go like this, it's going to move in that circular path and not lose contact. Okay, so Vmax is that maximum velocity. Beyond that, you'll lose contact. Okay, so I hope that's clear.